Hello everyone. Today we are going to solve problem maximum average subarray 1. So in this problem, I will first explain the intuition behind this problem. Then we will derive a optimal algorithm for this problem. After that, I will write Java code and we will analyze its time complexity and space complexity. So do watch this video till end. So let's start by understanding the problem first. So the problem saying we are given integer array nums consisting of n elements integer k. We have to find a contiguous subarray whose length is equal to k that has the maximum average value and we have to return that average value. Okay, let's come here and understand the problem carefully. So the problem saying we are given an integer array nums and an integer k. What we have to do? We have to find a subarray of length k whose average is maximum. So this problem is under sliding window problem was because we have to maintain a window of length 4. We have to maintain a subarray of length 4 whose average value is maximum. So in that case, I will first track the subarray of length k and I will calculate it average and I will track the maximum average value. And when uh, how I can do this? For this, I need a two pointer because sliding window work with two pointer. When how two point? Okay, let me show you here. What we will do here, I will use two pointer L and R. Find the window length L and R here, and the window length now is 0 because both pointing to same element. Now I start moving my R pointer but, until the window length become k. Here the window length become 2. Here 3. Here 4. Now the window length is 4. In that case, I will calculate the average for this sub array. Now what I will do, I will move this pointer again by one place, but in that case the window length exceed k. The requirement is of k here. For we have to maintain a sub array of length k, but now my sub array, now the window length is exceeding it consisting 5 element, but we have to store only 4 element in that window. So in that case, what I will do, I will shrink my window from left. In that case, I will move my left pointer by one place. Okay, that's how sliding window work. Whenever window size exceed, we we shrink from left side. Here I keep moving my R side window, and whenever it exceed that window size that we are given, in that case I simply shrink my window by from left to maintain that window. This is how we can check all window of length k and we can track the maximum average for that window. So let's understand how we are going to do that. Understand this. So what we have to return is we have to return average value. Okay, how we calculate average? The average is the sum of all element in that window. For example, if this is my window 1, 2, 3, 4. Here, if this is my window of 4, let's take it and bring it here. Now the window size is 4. In that case, now what will be the average for this window? The average will be the sum of all element in that window. If we sum all the value of that window and I divide the number of element of that window. So how many element in that window? It is k 4. So I simply divide it by k. This give me the average for this window. Again, I move my r by one place. It exceed the window size. So in that case, I simply shrink my window from left and again it uh, become a window of size. Again, I will calculate the average value for this window by summing all the element of that window and dividing by the size of the window, which is k. So this is the idea. So instead of what I will do here, instead of for calculating average for every window, simply track the maximum sum. Why? Because I know my average directly dependent on my sum, directly proportional to sum. If my sum is larger, my average will be larger, obviously. So in that case, instead of calculating average for every window, I will simply track the maximum sum of windows and whichever and I check the maximum sum, and at last I can simply return something like this, which return the average, because problem requirement is we have to return average of at last I can simply do this. So my idea is simple. I just check the maximum sum of sub array of length 4. Whenever my sub array length exceed my window length exceed, I shrink by from left. So yeah, this is the idea and intuition of this problem. The intuition is simple. Intuition, how I got the intuition of sliding window, because I know I have to maintain a sub array. I need to find a sub array of length k, which is fixed here. Okay, but we have to check all the possible sub array. In that case, the possible sub arrays be like, let's understand. The first sub array could be this window 1, 12, 5, 6. Other sub array could be this. Other sub array could be this. So here we know we have to maintain a window size, but also we have to check all the windows. In that case, the sliding window help. Sliding window simply check all the window. Whenever window exceed it, it shrink window from the left, and in this way it track all the window. This is the intuition. Whenever you uh, problem has mentioned something like this, where you have to find a sub array of a fixed length, and you have to explore all the sub array. In that case, sliding window helps. Okay, we have understood. Let's come here and code this so that we get the idea more clearly. Let's shrink this window first. Here come, and what we need in algorithm, we have discussed we need two pointer. With that two pointer, I will first find the window length of k, and whenever my window length exceed, I simply shrink window by from left. So I know I need a left pointer. Okay, what else I need? Other thing I need is max sum, because I need to track the maximum sum for the for every window. Max sum. Okay, and what other variable I need? A sum variable which store the sum of that sum array of that window. Okay, now I will run a for loop, which is my r pointer here. I will run a for loop. Okay, how long I will run this for loop? If I come here, I keep running my r until it reach the end. Once it reach the end here, there is no other window. I have taken all the window in consideration. So in, at this point, I simply stop my algorithm. So I keep running until I reach the end. That should be nums dot length. Okay, and I keep increasing my r by 1. Now what I need to do, I need to first calculate the sum. So I can do something like this. Instead of writing enter, I have already defined this variable, so I will not write again here. And what I will do here, I will simply keep summing. Okay, let me make a space here so it visible clearly. Now what I need to do, I check if my window exceed whenever. Let's understand here. Let's bring them at their previous step index. Okay, at this point the window length is 4. Although my index start from 0, so simply the difference is 3, but if I add 1, it become 4. So idea is if I reach that window of length k, in that case I simply track the maximum sum, and I reduce and I shrink window by one place so that it moves next and maintain a window length of k as well. Whenever my window length exceed or equal to k, in that case I track the maximum sum for that window and shrink window from left and increase window from right. So here, whenever my window length exceed, how can I calculate window length? R minus L plus 1, because index start from 0, so I need to add 1. Whenever it is equal to k or greater than k, in that case what I can do, I can simply track the maximum sum for that subarray. So how can I track? Max sum equal to math dot max, and whichever the maximum I will store in my max. And yeah, this is how I will track the maximum. And what I'm saying, whenever I am exceeding the window, in that case I shrink from left. So in that case, whenever I am shrinking my window. I am leaving this element. So I have to remove the value of this element from my sum because I am not including this element in my window. So I will not calculate in my sum as well. So simply what I can do, I will remove that value from my sum. Okay, I remove that value and I increment left pointer by one place. And at last, what I will do at last, I return the average. How can I return the average? Sum divided by the, we know uh, every window contain k elements. So in that case, it would be the max sum because I have to return the maximum average value for that sub array. So it will be like this. But what we have to return double, and this is integer because my int is integer, k is integer. In that case, to make it double, I can simply write double. I will convert typecast into double. Yeah, it is. Now I can return. Uh, yeah, we have written the algorithm. Let's run and check whether it's working or not. Okay, yeah, it's working. Let's submit it as well so that we can see whether it's applicable on all test cases or not. Okay, the problem is coming from here because we are initialize our max sum from 0, and whenever I am getting any value which is less than 0, in that case what we are doing here, we are checking only maximum. So in that case, instead of considering this value, it taking the maximum value, and between 0 and minus 1, the 0 is maximum. So in that case, we are getting 0. So here we have to make it negative value so that any negative value will be considered. So simply what I can do, I can make it negative value integer dot min value. This is silly mistake. Whenever we are checking a maximum value, in that case we should start from minimum value. Negative means infinite minimum value. Okay, let's rerun and okay, let's submit it. And yes, it's working. So let's come here and understand what's the time complexity and space complexity for this problem. So the time complexity is clearly visible. We are traversing over every element only once because we are running a for loop. There is no any nested for loop, nothing else. So in that case, my time complexity will be linear, and what will be my space complexity? So the space complexity is constant here. Why? Because I'm not taking any extra space, no any extra array and anything. We are simply using these three variable, and this variable take constant space. So in that case, my space complexity will be constant and time complexity will be linear. Hope so you like the explanation. If so, please consider to subscribe my channel and like my video. Thank you for your support.